Okay, so you've built an incredible generative AI application on AWS. It's smart, it's powerful, it's ready to change the game. But, as developers, we are wired to ask that one single critical question before we ship anything.
Is this thing really secure? Because let's be honest, in the world of cloud and AI, all that power without the right protection, well, it's not just a risk. It's a ticking time bomb for a data breach or worse, a model that can be turned against you.
To really get our heads around this, let's use an analogy that'll stick. I want you to think of your Gen AI app as a super high-performance car. You wouldn't just be bragging about the horsepower, right? No way. You'd be obsessed with the brakes, the airbags, the seatbelts, the entire safety system. And that's exactly how we need to think about security on AWS. So, sticking with our car analogy, let's start with the absolute basics. Who gets to drive this car in the first place, and where do we keep the keys? This is all about identity and access. In our car, AWS Identity and Access Management, or IAM, that's your seatbelt. It is your first and frankly most important line of defense. And it all works because of one beautiful, simple principle: deny by default. This means unless you are explicitly given permission to do something, the answer is always no. This one rule prevents so many accidental problems before they even have a chance to start. Now, IAM policies, they come in two main flavors, and you've got to know the difference. You've got identity-based policies, which you attach to a person or a service. They answer the question, what can this person do? Then you have resource-based policies. These get attached directly to the thing you're protecting, like a database. And they answer, who is allowed to touch this thing? Getting these two to work together is the key to locking things down tight. And that brings us to the classic trap. We've all been there. You're trying to build a prototype, you're moving fast, and that little voice in your head, or maybe a teammate, says, hey, just give it admin access for now, we'll fix it later. This is probably one of the most dangerous shortcuts in all of cloud development. Yeah, that is just the wrong move. Giving a service admin access isn't like giving a valet the keys to your car. It's like giving them the keys to your house, your office, your safe, the whole shebang. The principle of least privilege, it's not a friendly suggestion. It's the absolute bedrock of good security. You grant only the exact permissions needed to do the job and not one bit more. So, if IAM is managing the driver, where do we keep the actual keys? Well, I can tell you where you don't keep them. And that's hard-coded in your code or stuffed into environment variables. That's like leaving the keys under the floor mat. Instead, you use AWS Secrets Manager. It's like a fortified vault that not only stores your credentials, but can automatically rotate them for you, which just shrinks the window of opportunity for any attacker. Okay, so we've secured the driver and we've locked up the keys. Now it's time to build the armored car itself. This whole next layer is about protecting your data and the network it lives on. I want you to think of AWS Key Management Service, or KMS, as the locked glove box inside your armored car. See, even if someone manages to break into the car, they still can't get what's inside the glove box. And this is a really important shift in thinking. Instead of just trying to protect the data itself, you focus all your energy on ruthlessly controlling access to the keys that unlock the data. Without the key, any stolen data is just useless gibberish. And of course, your armored car shouldn't be driving around on public streets, right? It needs to stay within a secure, fenced-in property. In AWS, that's your virtual private cloud, your VPC. Inside this digital compound, you use security groups as little firewalls for each service and network ACLs as the guards at the main gate. And here's the kicker. To make sure traffic between your services never, ever touches the public internet, you use AWS Private Rank. It literally creates a completely isolated digital fortress for your app. All right, now we get to the really cool modern stuff. We've got our driver, our keys, our armored car, but every modern vehicle needs a dash cam to see what's happening. And more importantly, we have to make sure our super intelligent AI copilot can't be tricked. So here's your security dash cam toolkit. CloudTrail, that's the dash cam itself. It records every single API call, so you always have proof of who did what and when. AWS Config, that's like the car's maintenance log. It tracks every change to your setup, making sure you stay compliant. And then you have organization SCPs. Think of these as the strict, non-negotiable rules for the entire fleet of cars. Like a rule that says, no car in this fleet is ever allowed to have its public internet door unlocked, period. Okay, but here it is, the billion-dollar question for Gen AI. All this infrastructure security we've talked about is fantastic. It's absolutely crucial. But what about the large language model that's the brains of the whole operation? How do you stop your AI copilot from being manipulated?
Well, here's how they try. It's called a prompt injection attack. So an attacker will hide a malicious command inside a totally innocent-looking document. Then your application, just doing its job, goes and fetches this document to answer a user's question. The problem is, when the LLM reads that document, it can't tell the difference between the real content and the hidden command, so it just does what it's told and follows the malicious instruction. So how on earth do we defend our copilot? Well, first, you use tools built for this very problem, like Amazon Bedrock's guardrails, which have filters specifically designed to spot these attacks. Second, and this is a huge mental shift, you have to start treating every single document your app retrieves as untrusted input. Assume it could be hostile. And finally, you get proactive. You use services like Amazon Macy to constantly scan your data, making sure sensitive PII can't be pulled out in the first place.
All right, theory is great, but let's actually put all these pieces together. Let's see how these systems work as a team in a real-world example and get our Gen AI application on the road, the secure way. So, let's imagine an app that takes audio recordings from a dentist and generates notes. I mean, this is super sensitive data. So we build security in from the ground up. First, the audio is encrypted with KMS. All the processing happens inside a private VPC, completely cut off from the internet. The IAM roles have the bare minimum permissions, no broad S3 access. Of course, Bedrock guardrails are turned on to stop prompt injection, and a top-level SCP makes sure that our audit log, our dashcam, can never be turned off. See? Every single control is working together. You can think of this slide as your security playbook. Seriously, it's a cheat sheet. If you've got a challenge, here's the AWS control that wins. You need to prove who did what? That's CloudTrail. You need to encrypt everything and control the keys? That's KMS. Worried about prompt injection? Bedrock guardrails. Trying to stop secrets from leaking? Secrets Manager. For every major security challenge, there is a specific control designed to solve it. So, as we wrap up, I just want to leave you with this one thought. Your amazing, powerful Gen AI application, it's out there on the road, and it's going to go amazing places. But before you hand over the keys, have you done your final safety check? Have you checked the seat belts? Have you locked all the doors? And are you absolutely 100% sure that the dash cam is on and recording?